All right, so when we're talking dividing polynomials, there's actually several ways that we're going to talk about. But like we did with multiplying, we'll just kind of work our way up and divide some pretty long polynomials at the end here eventually. But first of all, let's talk dividing by a monomial. Of course, monomial meaning something that's one term only. So we're going to be dividing. The bottom here is going to be, it's just a one-term deal. So let's say I divide 6z squared plus, 6z squared minus 12z plus 18 divide by 2z. That's a monomial on the bottom. So we're dividing by a monomial. Well, turns out in that case, dividing by a monomial, what they're going to want us to do here is just simply take this 2z, it's underneath all that trinomial there. That 2z, in other words, is going to divide the 6z squared. It's going to divide the 12z, minus 12z, and it's going to divide the 18. Right? That's what that means. So that's what they're going to want us to do, is individually separate that out and divide each of those separately by 2z. One way we could go about this. And so we do that. Well, that just sets up, well, cancellation, doesn't it? Just like we were doing in a previous section there. We can just do all sorts of canceling. Like on this one, what can I do? Cancel the 6 into the 2. Goes 3 times. And what about the z's? Subtraction, because you got z to the second divided by z to the first. Yeah, that's going to cancel and give me z to the first there. So this is 3z to the first, or just 3z up front here. Just canceling. Now something even nicer happens in the middle, doesn't it? In the middle we got 2 going into 12. And leaves me a 6 on the top there. And then what about the z's? They cancel out altogether. You got same thing on the top as you do on the bottom. So those do cancel out. So in the middle, here we just have a minus 6, don't we? Now on the end, well, we can cancel the 2 and the 18. Goes 9 times there. What about the z? Well, there's nothing up here to do anything with, so it's just going to have to stay a z in the denominator. Is what they will have in mind there. Okay? So that's what they want us to do. Dividing by a monomial, separate it separately all out like that. All right? Okay, so what about 8xy to the 4th plus 6x squared y plus 12xy divided by 4x squared y. So again, I'm dividing by monomial, one term only. So they're just going to want us to separate it all out here. Separately divide by 4x squared y each of these terms on the top. So 6x squared y, divide it by 4x squared y also, and then 12xy divide by 4x squared y also. Okay? And then do the cancel. Well, the 4 goes into the 8 nicely, 2 times. Now what about the x's here? Well, we have sort of a problem because you've got x squared in the bottom and x to the first in the top. Number of ways you can look at it. We are subtracting. If you outright subtract, it would be x to the negative 1 power, but I look at it, I've got more in the bottom, so that's where the x to the first is going to be eventually, right? Whether you do that in one step or two. the x to the first is going to go on the bottom. Now the y's, well, those are going to be canceling out, aren't they? That being y to the first, so I'm going to get a y to the third, and it's going to be in the top. So I'm going to have x to the first in the bottom, a y to the third in the top, because of the way the exponents are working there. So I'll have this. It's a little messy there. Believe that? 2y cubed over x is what the first simplifies out to be. Now, a little bit nicer on the middle term, because the x squared, well, that cancels. The y, that cancels. So the variables in the middle cancel out. The deal on the coefficients, though, well, they don't. 4 doesn't exactly go evenly into 6, but 2 does. So I can reduce those by 2. One way I can do it. So I have a 3 over 2 in the middle. Okay with that? And then last but not least, over here, well, the 4 goes into the 12 3 times. The y's do cancel. Then I've got that x over x squared thing again. And so what happens there? You got an x in the bottom. X to the first is going to wind up canceling out, and we'll have an x to the first, or x in the bottom. So I'm seeing 3 on top, x on the bottom. That's how they'll want those. Okay? Question or concern on dividing by monomial? All right. Well, guess what we do next? Well, number 2 on dividing here is dividing by a binomial or even higher. All right. A little bit more of a process when you get that binomial that you're dividing by, binomial or higher instead of a monomial. Let's start with this one. 6k cubed plus 11k squared minus 6k plus 7 divided by 2k plus 5. So there you go. There's a dividing by binomial, isn't it? So, yeah, the thing of it is you can't break it down like we did this. You can't separate this. It just doesn't work quite out that way. So we're going to do this a little differently. What we're going to do here is use a little process we like to refer to as long division. Okay? And sometimes that is very aptly named because it takes a little bit of a process to do this, but it's once you get the process, it's just repeating the process until you get finished. So let's see if we can work our way through it. All right, so if I want to divide this out, let me erase this and do it right here so I'll have plenty of room. All right, so I'm going to put my division bar here, and 6k cubed, 11k squared minus 6k plus 7. It's going to go underneath there. 2k plus 5 is my divisor. So the divisor goes on the side like that. Okay. And so the process starts like this. What I do is I divide the first term of the top by the first term on the bottom. 6k cubed, I'm going to divide that by 2k. And that's going to go the first part on the top of my answer. Well, if I do that, what is that? 6k cubed divided by 2k. The good thing about it is, the dividing works usually out pretty nicely. 6 divided by 2 is 3. What about k cubed divided by k to the first would be k second. Yeah. Subtracting there. So you usually wind up with a pretty nice little number there. Okay, but I have to take that number and do something with it, and that is I have to multiply this expression by my divisor over here. In other words, distribute it amongst those two terms. 3k squared times 2k is 6k cubed. And then 3k squared times 5 is 15k squared. And notice I'm writing them underneath a k cubed and a k squared term because those are going to line up nicely there. Okay? Now, when you're doing long division of just a regular number, you then take this minus that. Do the same thing here. We're going to subtract these from these, which means if I subtract these, doesn't that mean change their signs? Yeah, so the next step here, I guess step 3, is change the signs of your lower part there, because you are subtracting, so changing signs happens. And that's good because on the first parts here, what happens? 6k cubed minus 6k cubed. That's 0, isn't it? So we do want that. Now on the second ones though, 11 minus 15, k squareds, well, that one doesn't cancel out. We get a minus 4k squared, don't we? Okay? And that's the process. Now, we have to repeat that process until we get to where we can't do any more. Bring down the next term here and repeat that process. So who remembers the process? Well, we'll do it a couple of times. What do we first do? We divide the first two. Yeah, we take the minus 4k squared, first one here now, and divide it by the 2k, first one of my divisor. And that's going to go alongside the 3k squared. Let me get rid of some of these arrows here. Well, negative 4 divided by 2 is negative 2. And then k squared divided by k to the first is k to the first, isn't it? All right, well, we've already done 3k squared, so we're ignoring it right now. We just go with the minus 2k, take it times the divisor over here. So minus 2k times the 2k plus 5. So minus 2k times 2k is minus 4k squared. And then minus 2 times 5 is minus 10k, and that lines up very nicely there. Now, very important step is next. Easy to forget, though. What do we do next? Change signs. Change that to a plus, change that to a plus. I like to mark them out, show that I changed them. They're there. And nicely, you got minus 4k squared plus 4k squared, don't you? Go out nicely. Minus 6k plus 10k, well, that's 4k. So we bring down the next one and do this one more time. Bring down the plus 7, yeah. And do it one more time. Because we're out of terms then, aren't we? Okay. Okay, so 4k, going to take that, divided by 2k. 4 divided by 2 is 2, and then the k's cancel out, so it's just 2, positive 2. And you do want a sign there. It's 2, but it does need a positive in front to separate the terms. Okay, so then what? Yeah, take the 2, multiply it by your divisor here. So 2 times 2k is 4k, and 2 times 5 is 10, positive. And change the signs. So that makes a minus and a minus. 4k minus 4k is 0. 7 minus 10 is negative 3. All right. So we're done. Fine. Long division. Like I said, it's usually a good name. Okay. So here's how, the answer. Turns out this right here is referred to as the quotient of your answer. And this, of course, is the remainder. And yeah, you can write it up there. Let me just rewrite it down here. As far as the answer goes, you take your quotient, 3k squared, minus 2k plus 2. And then add to that the remainder, negative 3 over the divisor 2k plus 5. That's how answers should appear. Now you might note there I could just say minus and then 3 over 2k plus 5 if you prefer. But that would be one correct way of doing it. Okay? All right. Let's do another. Six x cubed minus 8x minus 15 divided by x squared plus 4. See what happens there. Okay, well, first of all, let me point out one thing that we should always be on the watch for on these dividing ones: missing terms. Be sure to look for missing terms, because those can really mess you up. Just so happens I have a couple of missing terms here on the top. By missing terms, I mean, when I was doing this one, I had k cubed, k squared, k to the first, constant. Doesn't quite flow that way on the top here, does it? Because I've got x cubed and then x, and then what's missing? X squared is missing, okay? X squared is missing here. Now I can say something too, it won't always be true, but I'm also missing something in the bottom, aren't I? What's missing in the bottom? The x term is missing. Is everybody okay with me on that? Yeah, if I was going in true descending powers, I'd need an x cubed and then an x squared. Well, I don't have an x squared, so let's make note of that. And down here, I've got x squared and then the constant, so I skipped over the x term. Okay, so that's what I mean by missing term. So what I'm going to do, in cases such as that, better save this all for my work, but what I'm going to do is, let's rewrite this problem and say it's 6x cubed plus, I'm going to fill in the x squared term, but I can't just say x squared because that would make it a little different, but I could say 0x squared, couldn't I? Because 0 times anything is 0, so essentially I've added 0 to this. But it'll help out if I do that. So what am I going to do on the bottom? X squared plus 0x. So yeah, any term that's missing, just put it in there with a 0 coefficient. And that'll make things all line up better. Okay, so let's do this one. So let's divide x squared plus 0x plus 4. Divide that into 6x cubed plus 0x squared minus 8x minus 15. And everything will all work out well here. Okay. All right. So how do we start? Divide the first parts. What do I get? 6x, don't I? Just 6x. So then I take the 6x times all here, so that would be 6x cubed, 0x squared, 24x. Yeah, this one actually turns out really short. Okay? Change the signs. So all those become minus. What happens? Those make 0. Well, 0 x squared minus 0x squared is 0x squared in it. So those essentially, well, that won't always happen, but it does here. All right, and then minus 32x minus 15. Okay. So actually, yeah, I gave us a short one here. A short long division. Because, do you see, I can't go anywhere else with this? Why not? Well, because I'm dividing x squared, dividing it by 32x. Yeah, it's already a smaller power than what I had here in my divisor. So I can't divide this into that. So I'm done. I've got a smaller power here than so that's my remainder. Yeah, that's my remainder. And this is my quotient, so in this case I just have one little thing. All right, so it'd be 6x plus negative 32x minus 15 over x squared, and you can put 0x plus 4, but at this point you don't have to. Okay. All right. Okay. Now, let me do this one. 2x squared plus x minus 10 divided by x minus 2. Just to make a quick point or two about this. If I do that long division, what happens is this. I go 2x squared divided by x. That's 2x, isn't it? Then I have 2x times x minus 2. That'll be 2x times x is 2x squared. 2x times minus 2 is minus 4x. Change the signs. The 2x squareds are out. X plus 4x is 5x. Bring down the minus 10 and do it all over again. I can't do one more because, yeah, I can take 5x, divide by x, it'll be positive 5. And so that will make 5 times x, 5x, and 5 times minus 2 is minus 10. And that's why I bring this one up, or one of the reasons I bring this one up. It's because when I change those signs, what happens? 0, right? 0 left. That's 0, that's 0. Yeah, I wind up with a 0 remainder here. And so when I write my answer, 2x plus 5 plus 0 divided by x minus 2, is this part really necessary? No. You can just leave that part off. In this case, the answer just comes out being 2x plus 5. So sometimes, yeah, you get that 0 remainder, and